All right, thank you everybody for coming. Patrick is preparing his demo. I'm Andy, and this is the Spark Meetup at Sharethrough. We're going to have a 10-minute presentation by Patrick Wendell first about the upcoming roadmap for Spark releases, and then we're going to have a presentation by Ryan from Sharethrough about their applications using Spark streaming. I want to say thanks to Sharethrough for hosting the meetup tonight. It's no small feat financially or logistically to host these sort of meetups, and they, like everybody else that does them, volunteered it free of charge to our community. So let's give them a hand. Especially Jessica over here, and Robert, who I don't know if is here or not, and Ryan, of course, for volunteering to talk. So I also want to mention that we have another meetup in the South Bay coming up at Huawei on February 5th. It's also going to start at 6:30 with a talk at 7. It's on simple deployment with Simmer, which is the Spark inside of MapReduce application, and advanced Shark analytics with table generating functions. And that'll be by Ali Godsi. And then finally, before we let Patrick start, I want to mention that the second Spark Summit will be this summer at the very end of June. Beginning of July, and we will be announcing that in the next few weeks, so be sure to keep that portion of your calendar clear. Looks like it'll probably be June 30th through July 2nd, and in San Francisco. So I think that's all the announcements we have tonight. Oh, also thanks to Databricks for making sure that the streaming happened and the video is happening professionally tonight, so that everybody that wasn't able to make it in person can be able to watch streaming online right now, or within a couple of days watch it online, all for free, of course. And now we'll hand it over to Patrick, who is going to talk about the upcoming roadmaps.
What about now? Any luck? Here, I think, oh. Okay, I've been told to stay behind these two speakers, so there's a virtual wall. Yeah, I'll keep myself back here. Okay, so hi everyone. My name's Patrick Wendell. I'm a committer on Spark. I work at Databricks, and I helped coordinate this most recent Spark release. So I'm giving a quick talk here on the release before the kind of main event tonight. Just covering what's in it and various other things. So facts and figures. This release had 90 contributors, so that's like a huge number, obviously. It's a 404 pull requests. Every one of those was reviewed and looked at and eventually merged. And it's a 4-month development cycle for this 0.9 release since the last major release, which was the 0.80 release. Also, the status with this release is that we cut a release candidate yesterday, which is now being voted on. That's how the Apache process works, is you cut a release candidate, it gets voted. But it looks like this one or a subsequent candidate is likely to get fully voted to be the 0.9 release in a matter of the next few days. So this is kind of exciting because it's the most, in every dimension here, it's kind of the most ever, or the fastest amount of development that we've had. Yeah, this continues to be like a very quickly growing community. So what are we focused on for this 0.90 release? A lot of it's around API stability and marching towards what is going to be the Spark 1.0 release. Once we hit 1.0, we're going to preserve ideally compatibility inside of that release. So we're really focused on doing any kind of API changes that need to happen, getting them done now. Although in general, we try to be very conservative about changing APIs overall in the projects, but anything that we need to do, we're trying to do it now. So it's API stability, usability, and overall stability of the code base. And increasingly what's exciting in the Spark project is not just the core computing engine, but the libraries and frameworks that are on top of Spark, which are kind of distributed with Spark. So it's a batteries included model where you get higher level things, many of which come with the Spark packages. So in that case, here some that are highlighted are streaming, ML, and GraphX. I'll talk about all of those in this overview. So all that said, we still are improving the kind of core Spark engine. some things that went into this release that are significant. In the standalone mode, which is a basic resource manager that's distributed with Spark, we've added the ability to run your entire application inside of the cluster. So it used to work such that the only way to run it was you'd run the kind of driver node, the central component of Spark, outside of the cluster. You connect to the cluster to launch some slaves. But now you can sort of put your entire application in the cluster. And this has two benefits. One is that if you're behind a firewall or something, you can't easily just launch the driver node from you don't have access to sort of the internal network of the cluster. You can now just totally ship the thing and run it in the cluster. The second is that we can do some high availability monitoring of your job and make sure that the driver restarts if there are problems. We've added external spilling for high memory reduces. So this is on the reduce side of a shuffle. If you accidentally overload one reducer, the previous behavior was that it could run out of memory, which is not a great usability trait. And now what it does is it will actually do external sorting, so it will page stuff out to disk. All that said, if you are seeing disk spilling when you do a large job, you should consider adding more reducers and trying to spread out your data to get better parallelism. You'll see much better performance. And lastly, we have improved the stability of Yarn. There's just more and more patches going in to kind of fix corner cases in that deployment mode. Okay, the configuration system. This is another API standardization issue. We've added this Spark conf class. So the way that you configure Spark now is you just pass it a Spark conf, very similar to the way like Hadoop conf works. If anyone's job conf works in Hadoop, if you're familiar with that. This is helps with a lot of things. Just gives you a consistent way to do configuration. It is backwards compatible, so if you've been setting Java system properties, those work. But we recommend that users shift to this way of doing it for the future. So Spark streaming, there's actually a whole bunch of improvements here, which you can go read the release notes. I just picked out a few of them to highlight. One is that this is no longer we don't consider it alpha anymore. So the API is stable, and you should expect it to be non-alpha software. We've added a bunch of instrumentation hooks for doing things like monitoring performance of streams, and that will eventually be the basis of a UI that's dedicated for Spark streaming in a future release. And several optimizations have been introduced at various places. By the way, just while I'm talking about this, I want to have TD just stand up and wave to everyone. So TD is the Spark streaming guy. Yeah, everyone say hi to TD. So if you have questions, oh wow, congratulations. If you have questions about Spark streaming, he's the person to reach out to after the talks. Because there's a whole bunch of stuff I didn't cover there that he can tell you about. So MLlib, we added a Python interface to MLlib using the NumPy data representation and a naive Bayes classifier, some better improvements to the alternating least squares algorithm that adds parallelization. And also, we've increased the documentation overall. This is something we are really focused on, is making sure there's good docs for these higher level libraries so that people understand how to use them. Okay, GraphX. So this is a new in Spark 0.9. It's a code base that was developed in parallel as part of a research project, and it's become increasingly mature and stable to the point where now it's merged inside of Spark as an alpha feature. The whole idea of GraphX is to give you the ability to convert RDDs into a graph data structure and do write sort of computation, write essentially graphical computation where you reason about edges and vertices, et cetera. And the nice thing is it's totally integrated into Spark. So if you're already dealing with RDDs, you've kind of represented your data in Spark, you can convert it to a graph, do some computation, convert it back into whatever data format you're comfortable with to export it. Let's see. So yeah, there's operators to transform graphs, to prune them and create subgraphs. Then we've also there's an optimized Pragle API in here, which I think is sort of subsuming this existing piece of Spark called Bagel, which is a very small amount of code that actually a lot of people use to do, which exposes this Pragle type API. So I think over time this is going to become the de facto way to do this in Spark. Also, there's some standard implementations of PageRank and other graphical algorithms, so people can go use those directly. They also are a representative of how you would use the API to build different types of algorithms. I'll keep going, and if there's any questions about this, we can answer them at the end. Okay, last I just want to wrap up with a bunch of smaller features that are in this release. So. By the way, this entire talk is in no way exhaustive, so please read the release notes and check out. There's just so much stuff that ended up in this release, and we're super excited about it. But these are some of the ones I thought might be notable. There are some minor API changes here. So one is that this dstream and paired dstream, these are the RDD equivalents in the Spark streaming package. So they're kind of the fundamental data type. They got moved into a different package just called dstream. So all that users need to do is just change the import to add one more line in the import statement. But other things are that we've moved the start and stop scripts for the cluster. These are kind of things that system administrators might deal with into a separate sbin directory. That's because in many deployments, people want to set permissions differently for those things. And it's just kind of a standard way of doing file layout within a project like this. Consequently, we also moved Spark Shell and some other kind of important things into a bin folder. So if you download this release and you start typing on the Spark Shell and you see that it's gone, it just moved into bin Spark Shell, and don't worry, everything's still there. There was a few new operators added, approximate, count distinct, and a histogram operator. There's also a usability thing that is near and dear to my heart, which is that if you don't add a log4j properties file, or somehow you're using Spark in a way that you've bundled it up and doesn't include a log4j file, it has like nice default behavior around logging that it will detect that you haven't configured it and just add nice default logging. So this is nice because if you don't have this feature and you accidentally forget to include a log file, it's very hard to figure out what the heck's going on because suddenly you have like no output from your application. OK, so I think that's just kind of a whirlwind tour of features. What's the status? So you can try this release. Currently, we're voting on it. So the final release won't be out for a few more days. But once it is out, you can go to the normal download page, and everything will be there, including the release notes and so on. Also, one way to get started with playing around with Spark 090 once it is fully out there is to spin up an EC2 cluster. That's kind of a fun way to go and play with it and type on the Spark shell, and you can access data sets that are in the cloud. And I just put the instructions here because I think it's a good way to get started with the release. So OK, so I'm just about out of time. But with that, are there any questions about the release? And I might enlist other Spark committers to help me answer them if there are. Anything? OK, sure.
Will this version of Spark be compatible with Scala 2.10?
Oh, you know what? That's actually one of the most important things.
Repeat the question.
Yeah. I had that on the slide, but I must have taken it out by accident. So one of the very most important things in this release, which should not be understated, is what the question was about, which is, will this release support Scala 2.10? Yes, this release upgrades Spark to Scala 2.10. That's like a huge thing that I completely left out. So if you use Scala 2.10, if you want to use libraries that are only available for Scala 2.10, you can do that with this release. So that's a big one. By the way, now that this makes me think, anything else I should mention, Matei or TD, that I left out? That's the bit. That was the elephant in the room. OK, maybe one more question, if there's anyone who has it. OK.
All right, great.
All right, thanks, everyone.
Thanks, Patrick.
Yeah.
OK, I thought of a couple more announcements. One is, please don't no-show to these. We had a wait list of over 40 people, and there's a few empty chairs here. I think it's partly my fault because we announced the streaming relatively late, and a lot of people realized that they'd be able to stay home and check it out on streaming. But we're actively brainstorming ways to offer a carrot to all of you in the community to not no-show at a meetup because it's free. And it's this ironic thing about events that when you make them free, you get a much lower attendance rate than when you make people pay for them. Also, just wanted to say thanks to Argus HD, who is the video vendor. They've been really great for our community. They do the summits, and they're helping us out now with the meetups as kind of we're exploring how it goes to do professional video for the meetups, and they're an awesome vendor for video stuff. So I recommend using them if your organization needs video work. And then if you want to host a meetup, we're always open to new people who are willing to buy all of us food and be able to speak for a few minutes in front of the rather large community, which is growing now that we have streaming at the meetups. Thanks again to Sharethrough for hosting, and that leads us into the Sharethrough part of the presentation, which will be given by Ryan Weald. who is a data scientist here at Sharethrough. He was awesome enough to give this a shorter version of this talk at the Spark Summit at the beginning of December, and we asked him to give a longer version of the talk because it was wildly popular, and it's a shining example of the community members picking up and extending and applying Spark, and in this case Spark streaming, to real applications. So let's put our hands together for Ryan. While we're waiting, how many people have gone to a meetup in the South Bay? Raise your hand. Yeah, to a Spark meetup in the South Bay ever. Okay, so our hypothesis is that we actually have 2 meetup groups that are currently kind of grouped together in one bucket in meetup.com, and we're considering splitting out into 2 meetup groups that are monthly meetups for Spark, one in the South Bay and one in San Francisco. And now that we're kind of considering the option or exploring the option of streaming all of the meetups, or at least some percentage of them, it might work well for us. How many people would be in favor of kind of more frequent meetups in San Francisco in this group? Let's say with streaming, where you'd be missing. So the idea here is that if we stream everyone, then you don't miss the ones in the South Bay. So let's say if we were to stream them all, how many people would be in favor of there being a monthly meetup in San Francisco? That's basically everybody here. So that's good. So we're considering the option of doing that if we can fill we actually have a little bit of an oversubscription for the people who are willing to talk at these things, which is great. So thanks for your feedback on that. Okay, Ryan's going to talk now. Stores, monoids, and dependency injection.
Wait. Oh, okay, there we go. Nice and loud again. Awesome. Every time. Yeah, so basically I'm going to talk about stores, monoids, and dependency injection. This is kind of a more in-depth version of the talk I gave at Spark Summit. I kind of cut out some of the extraneous parts and decided to focus mostly on the abstractions we found, because that seemed to be the thing that everyone really latched onto. And I'm going to talk in particular about a particular example so that we have some actual code and you can see how we use it. So basically what we're going to cover is just quickly a little overview of what Sharethrough is, what we do, and basically why we actually need Spark streaming, because it's always good to have context, otherwise you don't really need the tech. Then we're going to look at just the common patterns we've seen in our Spark streaming jobs. We're going to look at the way we use monoids as an abstraction for aggregation in Spark streaming. We're going to look then at the abstractions we use for saving the results of your jobs. And then finally, we're going to look at the way you use dependency injection, or we use dependency injection, and you could too, to basically tie everything together to improve your testability and developer happiness, because no developers like ops. So basically, what is Sharethrough? Sharethrough is essentially an advertising platform for the modern internet. Our goal is to have in-feed native-looking ads that match the form and function of an advertiser's site. For an example, we want to remove the annoying pop-up and make it more a nice ad that just fits within the publisher's form and function. Why that matters in the context of Spark streaming is basically, like most ad networks, we have a lot of data challenges that we have to tackle. Most of them involve real-time data, so we need to be able to track clicks in real time, impressions in real time. We need to be able to look at context of publishers' pages. We need to be able to look at what users have seen before so we can cap all those kind of traditional challenges you expect when you're running kind of an ad network or an ad platform at scale. Our challenges we face. And we chose Spark streaming to tackle those problems. So the question becomes why did we choose Spark streaming? Basically, one of the main backers was we liked the theoretical foundation of the mini batch way of tackling streaming. So a lot of other streaming libraries like Storm and Samza, they take more of the traditional it's a continuous stream. We liked the way Spark streaming uses the same mini batch computation using the underlying engine. That seemed nice. For us, the Scala code base and a functional API was a big plus. We're a big Scala shop, so that just fit in naturally to our developer cycle. The fact that it was a young project so we can contribute was super useful, so when we had problems with metrics, we just added them. And then finally, the batch model was appealing as well. The fact that you can get streaming and batch on the same platform, which minimizes ops, was really nice, especially since we do a lot of and we're looking to do more iterative machine learning algorithm work, which means you want a platform that's a little bit better than Hadoop for doing that stuff. So great, we decided to do Spark streaming. Then it was kind of the hard part, which is you actually have to maintain dozens of Spark streaming jobs, right? Pretty much as soon as you pick an actual piece of tech and settle on it, you quickly accumulate lots of code that's based on it, and that kind of quickly becomes a pain in the butt to maintain. So after having all these Spark streaming jobs written, we started to notice some common patterns, and then ways we could use functional programming to kind of tackle the complexity and dry up our code and improve developer reusability. Essentially, the common pattern we saw, which is no massive revelation, is essentially almost all jobs have the same flow, and that's map, aggregate, which lots of people call reduce. I think for us in particular, and for most people, it's even more a specialized type of reduce, which is usually just something that you can phrase as an aggregation. And then finally, you want to store that data somewhere, especially for streaming jobs where you're typically not writing out to a file system. You're usually writing out to some or multiple databases. So the real-world example we're going to look at in the context of that pattern is essentially a problem that we have to tackle that's kind of interesting, which is which publisher's pages has an ad unit appeared on. Right? This is used for lots of things, and it's cool for this talk because it follows that general pattern, and it has a couple of gotchas in the implementation. So the first step in any job is obviously the map phase. That's the phase that I think most people are pretty familiar with. Right? It's pretty basic. If you look at the code snippet here, it looks a little messy, but it's pretty easy to get the gist of it. We basically just have a raw HTTP request. We parse that request so that we can get the publisher's domain and also the clean path. And then we return that along with our creative key, right? That basic tuple that we return at the bottom there, creative and then clean pub page, will be the foundation that we work with throughout the rest of the job. The map phase, I think there's not a lot of really cool new abstractions defined here. It's basically just the common stuff, right? Pull things out of the actual Spark dependent code as much as you can, and your code tends to get cleaner. I didn't do a great job of that here because I want to be able to put it on the slide. But in your actual code, you want to extract out most of this stuff into other methods, obviously. So now we get to the more interesting phase, which is aggregation, right? So in this case, it's not a really clean aggregation of let's just add things up. It's kind of more of a fuzzy one. And at a high level, we can basically say what we want to do is we want to add each pub page to a unique set for each creative, right? Each creative needs to maintain a set of these publisher pages so that we can then either serialize those sets or write them out in some format that we can later materialize in other servers that serve real-time traffic. So if we take that, we can basically turn that into something that's a aggregation in Spark. The idea being we have sets of strings, right, which is obviously our pub page URLs. And then once we have that, we can do a simple reduce by key, passing it our sum, which simply adds new things to the set as we go along. So that works great in theory, and it probably works in testing as well. The problem is in production, that uses way too much memory as your data set grows, because you're talking about individual pub pages and you're talking about tons of impressions. That quickly grows to sets that are millions of items big, and that blows up your heap every single time. Even if you can get it to work on your heap then, when you try and rematerialize that later or query it from your database, you have massive problems. So really what we need is we need a probabilistic data structure that gives us more of a fixed memory bound, and the ideal data structure for that is a Bloom filter. Right? So we say, okay, our aggregation can no longer be the really basic aggregation we were hoping for. Now we need to start doing these more complex aggregations because it's streaming. Right? Bloom filters are kind of picky, kind of hard to deal with. So we're thinking total code rewrite. Definitely a bummer, right? Now somebody has to go in and implement a Bloom filter, and you have to figure out how to give the Bloom filter the same interface as the set, and then you have to figure out somehow how to patch that back into your Spark job where we had that sum method. And that's really where monoids really come in, right? The idea of a monoid being this nice abstraction that we can use to hide most of this complexity from developers who want to be able to write super simple jobs, right? If you're a data scientist, you want to be able to write simple jobs without having to worry about the implementation details of Bloom filter versus set. So the monoid is, like I said, it's a functional abstraction on top of aggregation. It has this really simple Scala form, which is essentially just a trait that has a 0, which, as you would expect, returns you the 0 representation of the thing you're trying to aggregate. So in the case of a set, it's an empty set, right? And then it has a plus method, and that basically takes set A and set B, combines them together, and returns you a set of type C. And the only caveat is that you always have to make sure that all of your aggregations are associative, right? So for a set, that works out well. For common addition, that works out well, but it's just good to keep in mind. So then we say, okay, let's take our set example from before and let's turn it into a monoid, right? So if we look at the code here, we can see it's actually pretty simple. As I said, all you need is a plus and a 0. The 0 is easy. It's just the empty set of type string. And then we're going to have a plus, and the plus is also pretty easy. We just delegate it off to the underlying set's ability to do joins. And then, as you can see, if you do set monoid plus on sets with 2 different items, you get a new set with both items. And as you would expect, you try and add 2 sets with the same item, you just get a new set with that item once. So you're probably thinking, like, that doesn't actually look like less code, that looks like more code, which is true. Conveniently, you don't actually have to worry about it because Twitter has already written most of that code for you. Twitter and the community, I should say. So Twitter has a project called AlgaBird, which is basically a large collection of monoids for most of these common aggregation tasks, including some of the more complex aggregations that we're talking about, like Bloom filters, sets, hyperloglog, all these types of things that you have to worry about when you're doing streaming are kind of provided for you underneath that abstraction of the monoid, right? With the idea being, you as an applications programmer don't have to worry about the systems challenges involved in like how to implement a Bloom filter, how to implement hyperloglog, and then how to actually like do the joins. You can kind of hide all that behind this common interface, which makes it much, much easier in your actual Spark dependent code. So if we take that example from before and we use Twitter's library for a Bloom filter, right, because we know we need to use a Bloom filter in production, it becomes very simple, right? We just create this Bloom filter monoid, and all we have to do is create a Bloom filter with all of our pub pages, and then at the end we just reduce them all and add them, right? So all that complexity of having to maintain your own like set monoid, Bloom filter monoid, it all kind of goes away, and it gets hidden behind this really clean, easy to use interface that makes it very simple. It also makes it simple, I didn't include an example here, but you can also imagine being able to use something like dependency injection so that in local testing you could use a regular set instead of a Bloom filter. And then when you get to production and you get to actual streaming use case, you can swap in the Bloom filter underneath the surface and make it so that it runs in production without a lot of extra complexity locally. So okay, so now we have that, and we can kind of start to see the benefits, but what we really want to do is we want to be able to iterate quickly, right? So somebody in product comes over to us and they say, that's cool. What I really want is I also want to be able to track like the set of unique users that's seen every creative as well, because pub page is great. I also need a set of unique users. And all of a sudden you're like, okay, great. Now I have to like modify this job to be able to count both things, right? Because we have that nice abstraction in place, it actually turns out to be a lot easier than you would expect. So here I've kind of included the monoid itself. This would obviously be like wrapped up into a utils package or into AlgaBird itself. But essentially, because we have this abstraction, the fact that it's now just a tuple of monoids is actually kind of hidden from the user, right? We can use the same interface, which is just reduced by key with an aggregator, calling the plus method, passing in both parameters, and it all just works, right? And at the end of that, we end up with our tuple of Bloom filters, nicely aggregated. And I forgot some parens. Awesome. So basically, monoids really equal reusable aggregation, particularly when you're talking about Spark streaming, right? There's a lot of those weird intricacies that we found where all of a sudden the traditional data structures that are easy to use start to kind of break down because streaming contexts, you have to deal with memory bounds in a continuous stream. And having the ability to easily drop in these probabilistic data structures underneath the same interface definitely makes it a lot easier for application development. So as I said, this is what our usual flow looks like. So now we've done map and aggregation. We're going to move on to storage. So the question is, like, how do we store the results of a streaming job, right? Spark out of the gate provides you with interfaces to write out to a file. We personally haven't used that a lot, because writing out to files tends to be not usually the interface you want to then consume your data in. Usually if you're writing out to streaming, you want to be able to like consume it on another server in real time. In our case, it's like you want to be able to quickly consume the data off your hop path, which is Spark streaming, and use it to inform ad rendering in real time. Using files for that is not a great interface. So really what we want is we want a storage API that's slightly more generic. We need to be able to support incremental updates, right? Like the disadvantage of streaming over batch is that you have to deal with like incrementally changing data. You don't have that nice like run a massive Hadoop job and get a whole chunk that you just drop in as the definitive source of truth. Instead, you have to deal with this continual computation that needs to update in your databases. We wanted to be able to have like pluggable support for different big data stores. You know, there's always operational challenges that everyone faces. Maybe your ops team's awesome at running Cassandra, but like not so awesome at running like a cluster of Redis. There's all those things, so we want it to be flexible enough that you can like plug and play different data stores as it becomes appropriate. And then we also wanted to allow for like easier testing of jobs, because obviously testing is super important if you're actually going to run in production, and there's definitely complexity involved when you're just writing out to files every single time. So essentially, you want a storage API that in Scala would look a little bit something like this, right? It's a very simple trait that's a mergeable store. It supports get, which is obviously a get, put, which is a straight replace, not an update, and then this idea of a merge. And the idea of the merge being it's a similar aggregation to what we had with our monoids before. It essentially takes an associative computation, and it like passes that associative computation off to the actual database itself, right? So in the case of Redis, this would be calling like the built-in incr command, which would like have Redis handle the concurrency and the incrementing. In MySQL, you'd like have to pass it to the MySQL client, and then you could increment like upsert or however you want to do it. Yeah, and then kind of the same thing. Rather than having to like write all of these things yourself again, there's already an awesome package out there by the guys at Twitter and the community at large, which is called Storehouse, and that basically provides this interface for most of the popular NoSQL stores at this point. So it supports like Redis, HBase, DynamoDB, Amazon's hosted version, MySQL, and it's very simple to write clients. We were able to write the DynamoDB one in a matter of days, so it makes it really easy to extend. So then using this interface, we can take a look at the code for saving the results of our job from earlier, right? So if we look at this, we see it's pretty simple. We're basically just going to iterate over the results, and we're going to call merge on our underlying store, right? In this case, there's a little bit of a problem with this job, and that's the fact that we've actually passed in a hard-coded HBase store, which is not great, because you end up having this problem, which is that not every developer has HBase installed locally, and you don't necessarily want every developer to have to install HBase locally, because it's difficult to install. You then have to have another Java process running on your work laptop, slows everything down, not awesome. And basically, that's where this idea of dependency injection really becomes super handy. Right? If you guys write software, you already know how useful dependency injection is, especially in the Java world. They all love dependency injection, and Spark itself uses a lot of dependency injection. And basically what we want is we want to take a generic storage interface for that job so that we can plug in the different stores depending on what environment we're in. Right? So we have an HBase store in production because we need to write to HBase because our data is huge. But in testing, we just want to be able to look at it locally. Right? We have no reason to write all the way out to HBase. We could use an in-memory store, for instance. So if we generalize our storage a little bit, we end up with an interface that looks a little bit something like this. The big difference you'll notice here is that rather than being able to pass in a store itself, I've had to pass in a storage factory. That's an interesting intricacy of the fact that most of the dependency injection frameworks don't support dependency injecting things with primitives particularly easily, and the Scala interface for that is really nasty. And also sometimes you want to be able to do like certain creation. So we found it's usually better to pass in a factory object. You dependency inject in a factory, and then you just call the create method on that factory, and that returns the actual store for you. Like most things in this talk, there's a theme, and that's you don't actually have to write it yourself. Google, this time, not Twitter, has done a good job of writing a framework. It's pretty much the standard, right? Everybody's heard of it. Google Juice. In the case of our job, we can use Juice to do something like this, right? We have the generic storage factory with a create that returns us a store that's string to Bloom filter. And then in dev, we want to bind it to an in-memory store. And in production, we want to bind it to the HBase storage factory. Right? And what that really gives you at the end of the day is like increased developer productivity and like faster test suite times because you're not writing out to a database. And it generally makes it a lot easier to do testing and also development because you don't need the distributed databases running locally. So taking our learnings, we want to be able to like give some stuff back to the community moving forward. So I've been talking to TD and working on trying to integrate in aggregation with algebra monoids and writing out to external stores into Spark in some way, whether it's an external library or integrated into the core, we're not sure yet. I'm still just trying to tackle a couple of like serialization issues with the stores themselves because some of them are hard to serialize. But hopefully in a couple weeks, we will be able to submit a pull request at some point that makes it so the community as a whole can take advantage of the monoid and store stuff. It definitely saves you a ton of time. I write a lot of Spark jobs, so it's definitely saved me a ton of time. And then also we're going to try and put some time into working on integrating Spark streaming into Twitter's Hummingbird project. I know they've had a lot of interest in that as well. They're more interested in batch, but we're interested in getting it as a streaming platform. The advantage here would be you'd be able to use the same logic that you use for your Hadoop jobs for your Spark streaming jobs, and then it will be up to the Hummingbird library to actually map them. So same thing, like bigger wins, and we're hoping that also means you can try and get more like community support around Spark because you don't have to have a like dedicated code that's tied to the Spark API, you can now have a more generic thing, which means you could swap in Storm or Hadoop when you're ready. And that's the end of that talk. I'm open to any questions you guys might have based on our experiences or this as a whole. Yes?
Why couldn't you use an implicit to get that stored in the scope?
You definitely could. So that's what I'm actually going to do.
Can you repeat the question?
Oh, yeah. So the question was, why couldn't I use an implicit to get that stored into scope? The answer is I definitely could. I tried to keep this code like slightly simpler and less idiomatic Scala, just so that if like there were people in the audience who were not like super familiar with Scala, it wouldn't be like totally confusing where the store was coming from. But yeah, definitely like in production we use implicits for all that stuff because it makes a lot of sense. And that's actually, I think, the really cool thing with the aggregation is that ideally you don't even have to do that aggregator dot plus underscore underscore every time, because that's extra typing you don't need. That just becomes an implicit on the value type from the group. Right? And then all of a sudden it becomes really easy, and there's like none of that typing, right? You just like define the implicit further up, and then it just works out of the box. Same goes for the store. So that's definitely what I've been trying to work on, and that's like where I've had some serialization issues, mostly for the stores. But yeah, those should be fixed because that's definitely a solvable problem. Yes.
Yeah, I'm curious with the stores, do they reuse connections across records? Is that a thing the library provides?
The answer is both yes and no. It really depends on like who implemented the actual store itself. Pretty much all of them do. Like they don't have a shared interface for that. It's kind of up to you because certain libraries have different things. So the ones that are provided by Finagle typically use like Finagle drivers, and then you get all of like Finagle's built-in connection pooling stuff. I know for like the DynamoDB stuff, we used like Amazon's built-in to their library connection pooling combined with like a background future pool, because the stores are all based on futures, so the whole thing's like non-blocking. So you have to like do a little bit of coercion if you have like blocking data stores that you want to integrate in. But yeah, there's definitely room for improvement of that stuff as well. But the Twitter guys are also really responsive when you have changes. So awesome, good stuff. And I'm always around if you guys have other questions later.
All right, let's thank Ryan. All right, before you go, can the other Sharethrough people who are here stand up? So we would love for anybody that's looking to join a company that uses Spark and is open to cutting edge stuff like what Ryan just talked about, to go talk to any of the people you see standing that are from Sharethrough. And we also encourage you to host meetups yourself, so that you can stand in their shoes as well. And we also encourage you to use Spark and Spark streaming as awesomely as they do. One other announcement I thought of is that the developer preview of SparkR was announced today. I don't know if all of you saw it, but SparkR is an R front end for Spark. So if you're familiar with the language R, it's one of the most popular languages of choice for data scientists and statisticians. It's Spark's API in R. It allows you to write code in R and then run that on a Spark cluster. You can get it already from the GitHub repo, which is github.com/amplab-extras/sparkr-pkg. Just look in your email if you're on the user or dev list, or search for the email on Apache's mailing list, or email one of us if you can't find it. Maybe we'll throw the URL up on the meetup.com group as well. All right, one more time, let's thank Sharethrough for hosting and Ryan for his talk.